So some of the design and construction concerns regarding the splice girder application, in terms of staging, running the dead load non-continuous and superimposed dead load and live load continuous, spliced girder construction, and deck replicability, pre-stressing for tendon modeling. As mentioned before, you can do it automatically or you can optimize it. And in terms of the splice girder construction, freely applying and taking out the temporary shoring or the strong backs. And for the deck replicability, modeling the deck, composite. And also replacement, meaning I'm actually referring to extending this to any rehab work can be actually done, modeled, analyzed in Midas Civil as well. And how are some of the design considerations can be, addressed when you actually model using the wizard, and the pier segment and the end segment considerations. How do you model them differently, and nonlinear temperature gradient loading too. In terms of the precast girder application, various type of girders, conventional I, bulb T, double T, box, tub, or void box, etc. Staging for the precast girder, and the raised band cap modeling, and geometric conditions such as curved, skewed, and the tendon modeling same as the splice girder. Before moving on to the demonstration, I would like to briefly walk you through the wizard. So this information you will also receive from me when I send you the release notice email. It's actually a part of the release note. So you can actually take a look at all detailed information about the improvements and developments that are implemented in 2016. So this wizard will generate a 3D FEA model really easily and in a very short time. And as you could tell, both the precast and the splice girder types can be modeled within this wizard. Looking at it, if you are familiar, if you have actually utilized or seen our steel composite bridge wizard that was released about a year ago, it's actually really the same. So once if you know how the steel composite bridge wizard works, it's actually the same flow and the same background the pre-post tension composite bridge wizard will work. So if you understand one or the other, you could easily get on the other one. Only difference in terms of the tab, the composition is the PC composite bridge wizard. We now have the tendon tab. So basically in layout, you can define overall information. What is the girder type, precast, spliced? How long is the span? How many are they? Is there any skew or curve to it? And which modeling type would you like to take, grillage or involving plate elements? And also at the bottom here, modeling with substructure or without substructure. In the section tab, detailed information about the sections, diaphragms in the tendon, defining any like pre or post tension profile, and straight, hard, or curved. Loading the conventional, the typical dead and live loads. If you need anything else as the varying temperature gradient loading, you can define them outside of wizard too. And construction stage, both for precast and spliced, considering different type of conditions for different type of girder, splice or precast girder. So in the section and the tendon tab, you will be able to find this type of information. So you can actually define various type of girder alignment. If you look at it, for the precast girder types, you can define same spacing, and the support lines are parallel to each other, or opposite spacing type. And the skew angle will be the same, but the support line will not be parallel to each other. For the splice girder type, for the curved structure, the girder can be either line or curved girder type following the deck curvature. The tendon assignment, giving you a brief overview. As you can tell, you can simply define any type of profile just based on D, H, H2, D2, and so on. So maximum like four dimension information to define them. And furthermore, there was another way to work it out. Remember, there is an automatic way too. This is more like just optimizing based on the typical the profile type. But if you want to kind of automatically insert them, we also support the Tendon database for the sections that we have the database for. And when you define your loadings, dead load, and various superimposed dead load, it's going to apply them in the most proper format as like this. So if you within Civil or in any other program, if you were ever curious, like, oh, I punched in this loading, but how is it being applied? You can actually visualize it within your model of Midas Civil, just like this. And also in terms of staging, this is a screenshot for a Splice girder construction stage example. So basically, the wizard will have a certain format set up already, but you could always customize the girder splice construction or details about the post tensioning, which one will be the second post tension or the first post tension. Those type of information can be either just by taken care by the wizard, and take the most conventional approach, or you can actually control them so that you can reflect all the details you need for your individual projects. Example sequences, which I'll be showing again in the program. So temporary support will be first applied, and then the end segment, and then the middle segment. And the post-tensioning can come first before the deck is poured. After the deck is poured, you can also second post-tension them too. And these are just various types of models that I created using the wizard. And as you can see the conventional I type or the box type, and this just the precast girder and the splice girder. So today, this post-tension or pre-tension, precast composite structure, it's something that we've been covering continuously. So some of the information that's been repeatedly covered in different trainings before in the past, those may not be covered all in detail. My purpose today is to show what are the changes now in Midas and how we can actually address some of the design and the construction concerns more easily with the new tools that we have in 2016. So if you actually didn't get full answers in terms of reviewing the stress details or something that's more specific and micro, you can actually refer to our trainings in the past. Session 3, which happened like a month ago, actually covered a post-tension structure more in detail. So yeah, today I'll be focusing more on how these new tools actually help accelerating modeling process, and actually little tweaks, the bend sections and the middle support sections, like how do we actually handle those parts. Okay, so before the program interface was just a typical Windows color, blue, but now it's kind of changed back to black and gray. So first, you can start the program by opening a new project. If you are actually new to the program, not sure how to start this, you can refer to our introductory training, or actually one-to-one contact our consultants or myself to get up to here. So basically, when you just open a model, you can now go straight to the wizard and the Prestressed composite bridge right here. Before we had up to steel, but now you can also see the Prestressed composite bridge. If this portion is ever grayed out for you, it's because either you do not have a license for the Girder module, or you just forgot to kind of check it when you connect your license. Either case, any question, feel free to let me know. So when you open the wizard, it's going to look the same as the steel one. And now it's composed of layout, section, tendon, loading, and construction stage that I briefly mentioned before. I'll be covering 2 examples today. I'll be actually walking you through step by step for precast example. And then for the splice one, I'll also show, but covering less of all the details that I already covered in the precast example. So in the layout tab, as mentioned before, you could basically define the geometric information, the overview of the structure. What girder type is it? Precast or splice? Simply choose. Span information, how many spans do you have and how does the length vary? It really don't matter. Just punch in the span information as what it is for your project. Layout offset, so basically the layout, we need to define it in order to define the support angle, the skew angle, or the curvature and so on. But the reference line will be by default at the centroid of the deck if the layout offset is just 0. So right now I'm going to set it as 0. It may be at somewhere else along the bridge deck in the transverse direction. Feel free to define it with the offset. Just adjust with this layout offset. Support skew angle if there's any. And then you can also pick the modeling type. Is it all frame, or you want to see the girder stress more carefully? You have freedom to choose. It's going to create entirely different model for the same structure, just with different compositions of element types. Deck width, for the example that I have, it's actually the girder to girder distance is about 9.6 feet, and the total deck width is 55.4. And if the structure is curved, you can check on this radius, define the curvature, and also for the curved structure, you could define either it is a same spacing over here or offset spacing. Anything that you're unsure of, always refer to our guide option right here. It's going to show you these pictures. And also, I forgot to mention this portion. When you choose your same spacing, the support angle will be different at each, at each support. So you have to pick which one will be your reference support. Abutment 1 or pier 1 or abutment 2, just let it know so it can actually define the support line parallel and handle from that point on. Boundary portion, exactly the same as the steel portion. So you can actually terminology change slightly to without substructure and with substructure. So basically modeling full, intermediate pier and the pier cap, or modeling without the substructure, just modeling up to the bearing and the support at the end. So you have an option. One of the things that I mentioned before is like the raised pier cap. I'll show you that portion at the end. I mean, after just executing the wizard outside this. But by the template of the wizard, it's going to model the pier cap underneath the girder. And after executing the wizard, I'll show how you can kind of do minor modifications to make those changes. Okay, coming to section, define the deck thickness. And then for the material, I have to select something, but I don't have anything. Whenever you encounter those situations, you can always click this dot button here, and you'll be redirected to a window in which you can define something that you need to pull up from the list. Okay, let me define my girder and the concrete deck and the tendon material. My girder will be grade C4000. And my deck portion will be just grade 3000. And I also need a steel material for the tendon. 416 to 70 low. I can modify the name too. Okay, so this way you can quickly define your material from our database and simply choose from this drop-down list. Okay, how many girders I have? I will have 6 girders. The number will apply the same. So this is where you can control how many girders you're going to have and where they are located exactly. As mentioned before, the girder to girder center distance is 9.6. So accordingly, I'm defining the locations of the girder. Okay. And also now it's a part where we can define the diaphragms. I don't have anything, so I'm going to click this, define diaphragm section, go to the section window, and define the sections newly. My diaphragm will be just a conventional, like the box types. I'm going to define the support diaphragm and also the intermediate between the girder to girder diaphragm. And my girder to girder diaphragm, I don't know if you noticed, but then the girder to girder distance that I left was about 5 feet. Let me actually get back to this portion, but remember that I defined the diaphragm of 5 feet thickness. And when I come back to the layout, I actually forgot to mention this portion, but you can specify the spacing between the girder ends and the support ends. And how this will help is it's actually the distance that will the girder will be disconnected during the stages before the deck is composite. So so after when the concrete is poured, it's actually going to be poured gapping, filling this gap between the girder to girder. So this is actually this gap can actually reflect the length of the girder that what is it? Like the above the pier, if the section isn't the exact same eye or whatever the case be, this is the length that you can reflect how far that the diaphragm section will cover. I think I'm making this a little more confusing than really what it is. I'll actually mention this part after modeling using the wizard, so that way you can connect this number and the model that's completed. But yeah, just note that I'm defining the spacing between girder to girder as 0.5 feet. Okay, coming back to the section. So I define my diaphragm. It's going to fill the girder to girder intermediate and at the support until the deck is poured. So here I can choose the proper diaphragm that I just defined. And you can also specify the angle type in case the structure is skewed or curved. And in the girder information, I can specify the girder for span 1 and span 2. The interface looks really simple since it's a precast application. But for Splice, we can actually specify the splice point and locations and so on. But here, right now, just exactly the same way as the diaphragm, I don't really have any section for the girder. So now I'm going to click this Define Girder section and define the girders that I need. So whenever you encounter, you have a drop-down list, but you don't have anything, you don't have to go out from the wizard. You can always find a button that's going to take you to the new window in which you can define what you need from this list. Okay, so I got redirected to the section properties window. Now I'm going to click this Add button. And this time, my girder, looking at the tabs, it seems like the PSC is what it's referring to, right? So I go to PSC. And then you're going to see a drop-down list with all the box, multi-cell, and here the conventional prestressed concrete sections. When you go to Prestressed Concrete I, you will see another set of drop-down list. Here, you're going to see the DOT names and AASHTO. And for each agency and AASHTO, we actually implemented all of their state database. So that way, you don't have to spend your time punching in the section information. Regarding this, as you probably noticed, for I section, we have about like 8 DOTs that we currently implemented the database for. I know, I know we have a lot of people from the southern states today, and also, upper east states. We have about like 30 firms attending from Florida. But for those, states that are intensively working in the PC application, we don't have the database yet. You know what you gotta do in this case? You have to let us know. Louder your voice is, like harder we work with you. So if you actually don't see your DOT database, let us know. You can let me know via email, or you can let any of the other consultants know regarding this. So that way we can actually bring that we are aware there's high demand for your DOT or any other agency. So that way we can actually support your work, make it faster, like all other states that we've been more closely working with. So I'm going to define this AASHTO type 5 girder. Apply. So I applied, and simply I just pull from the database and define it, right? If you need to modify this section, of course, you can actually change the values and reflect the change. So this is where it's going to help when you have to define, like the girder. At the intermediate pier portion. So if your girder has to be elongated at the flange or at the web portion, whatever the case be, for the splice girder, you will have to lengthen your the girder. Or for the pier, above the pier, for the concrete pour, if the bottom flange needs to be thicker, you can freely modify that any way you need. So from 0.6 to 0.5, I could increase my flange thickness like this. So this way you can freely manipulate the section that's according to based on the database. And before moving on to defining the composite section, I want to show you some of the further database that we have. So if you choose, if you look at our drop-down list, they are the conventional pre-stressed concrete sections, the box or middle, I, and T. So if you don't really see what you need, go to PSC value. You can actually import the AutoCAD here, via the section property calculator tool, or you can simply go to the data again and see over here if we have your database. Massachusetts DOT have quite extensive section database for prestressed concrete applications. So giving you an example, you can actually bring any of these sections into Midas and use them for this type of application too. So now, but for this one example that I'm covering, I will be working with AASHTO type 5. So I defined my girder already, as you can see from the list, AASHTO type 5 right here. And when you go to Composite tab, this is where you can define the Composite tab. So using this Composite, we are basically defining both the concrete portion and the girder portion at the same time. And the merit of it, I'll get back to it in a later, but just know, in order to use the wizard, you will have to define your girder and the composite. And the reason why you have to define the girder and then the composite is just because when you define your composite section here. You can punch in the slab information, very simple. It's the girder to girder distance, BC, and TC for the thickness of the deck, and hunch. And then for the girder portion, it seems like there's a lot of work to do, right? So many numbers to punch in, but you know, what's the point of us defining the girder right here? So that we can import it and make it composite right here, right? So this way, all these numbers, you don't have to punch in again. You can simply import from what you defined already. And then it's a composite section. However, we have to let the program know the different material property of the girder and the deck portion. So I checked on this select material from DB and picked the material for the slab portion and the girder portion. Remember, it was grade 3000 and grade 4000 for the deck and girder, respectively. So I just picked them. Say OK. According to those information, the program automatically computed the modular elasticity ratio. OK. Now I'm done. Gonna say OK and exit out. Oh, forgot to define my name. So program can also let you know with this pop-up window or in the message window right here if you've done anything wrong. Okay. So I'm done defining my girder. You can define however many girders you need, but yep. So coming back to the girder information, you now have the section appearing on your drop-down list. So pick it, span 2, yes, there we go. And this option, it seems really minor because it's just like, you know, almost not noticeable, but very, very important and useful. For an FEA program, it's difficult to extract the output at the 10th point. You have to manually configure the node and element ID, but with that option, you could have the program do that automatically for you. Okay, now in the tendon portion, I'm actually very proud of this tendon tab. So you can actually easily define your profile. For the precast example, a lot of cases the tendons are quite straight. A lot of cases. But if you have to work with hurt or bented for splice girder application, of course, but it's going to be very simple as just a straight. So step first, you can define the tendon assignment name. I'm going to define a set for the first span. And you can also define, next you have to define the tendon property. Click on add. And internal right here, you can pick if it's a pre-tension or post-tension or external. And material, remember we defined steel, so simply pick it. And then total tendon area, mine will be 1/2, and just 4 of them updated right here. And then for the relaxation coefficient, you can pick the database that you work with, CBFIP most likely, or you can user define them too. Going to choose this according to CBFIP. You can choose class 1 to 3 according to the code, and the ultimate strength, yield strength, will be there according to the tendon information you put in, but you could also freely modify them too. For the post-tension type, you can actually define the bonded or unbonded type. I get some of the questions that I received in the past are such as, according to your agency regulation, you have to, disregard the unbonded tendons. That way, you can simply define it unbonded and consider the different properties that come with the unbonded types. Or if you completely have to neglect them, you can simply just not define them at all. You have all the flexibility. Okay. And here for the segment, so it's going to give you span by span segment for the precast type. For the splice girder type, it's going to give you more than just the span 1 and span 2 segment. It's going to give you the segment per the, like the girders that are disconnected at the splice locations. So choose if it's straight, carved, or curved. So each time you pick the different type, it's going to, activate the cell or deactivate and so on. So straight one, tendon property, pre-tension. How many of them? There will be total 12 of them. And the transverse distance, there will be 11 at So this way, as you can tell from the picture here, you can zoom in and zoom out. I define my tendons just like this, 12 of them at 0.1667 feet apart. So same way you can define the information. For the sake of time, I actually just define them and put it in the spreadsheet. So I'm just going to copy them here. Okay, so this way you can review in the longitudinal direction, but also you can review in the cross-section view. So this is one way to work for defining your tendon profile. And another way that I constantly highlighted is doing the automatic way. I'm going to show you that one too. But let me first just work in this way, the wizard way at first. So after defining just like one set of the girder information, simply edit. I'm just going to define the same for the span 2. Anything more in the middle at the top flange, feel free to define them. And moving on to the loading portion, it's actually really same and something that you've always seen in Midas. The conventional, the dead load, and the after composite loadings can be defined very simply by just checking on the option you have to consider. And then the loading case type, or is it applied in the before composite state or after composite state? Those type of considerations will be done automatically according to the wizard. So, but it's really straightforward. So let me skip this portion. Moving on in the construction stage, it's relatively simple for the precast. So basically, this is a splice girder example. Let me first execute this wizard and come back to this. Oh, I haven't noticed, but then I'm actually running out of time a little bit. So let me quickly pinpoint this portion. Okay. Give me 1 second. I'm going to undo and change the offset for my girder. So this way, if you made any mistake, you can simply undo and repeat what you've done. Okay. My peers are offsetted wrong, but here, let me cover this portion. How to define different intermediate peer cap. Actually, let me do that with the splice girder application. Okay, so I have two more examples to show you. For the splice girder one, for the sake of time, I'm going to show you the input that I put in before. So just quickly change my unit setting to feet. Okay. So basically for the splice girder type, the minor differences are, that you can specify the splice girder location like this over here by checking on the guide option. When you check on the guide here, it's going to tell you exactly what these are. So basically, for the first division, we have a splice point right here. So I check on this. In the second one, that's going to be the long this hard portion. There won't be any splice up to the support. There's the splice point at the end here. So this way you can define your splice girder point. And this hunch portion, I defined a taper portion, but let me cover the portion after executing the widget. So basically, very similar format. Tension is also defined. And the one major difference comes in the construction stage. So for the splice girder construction, you can actually control the girder splice construction stage, meaning you can actually control the sequence of the girder installation. And also you can control the location of the temporary support position. So whether you have your support or the strong backs, you can actually reflect it by just pinpointing where is the those SP splice girder points. And post-tensioning tendons, so if you have multiple tendons, if you have the first tendon apply post-tensioning before the deck is poured, you put them as the first tendons. If you have to consider post-tension them after the deck is poured, you put them in the second tendon. So this way you can distinguish which one will the tensioning sequence right here. And according to what you choose, it's going to create these stages. Remember I mentioned that portion, you will need an advanced type of license if you are working with a splice girder type, because the construction stage will most likely be more than 10 or around there if you're working for a splice girder application. But as long as you keep the stage number to like under 10, you may be fine. While we give it some time to generate it, okay, it's generated. So it's actually the same as the precast example, but let me go over the stage to actually visualize different sequencing. I'm going to change the color of the sections. It's too colorful. Okay. Stage 1, the middle, the support girders are casted. And then stage 2, the end girders are erected. You can see the temporary supports are applied, holding the longitudinal and the transverse slip. Stage 3, the middle deck is casted. And over here, if you noticed, let me display my tendons. The tendons have been there for the girders. So these are the pre-tensioned tendons. And then you can post-tension them once they are all placed. So you can make them, continuous. You can apply the first post-tension. And then in part 4, this is where the wet concrete is poured. And in stage 4-2, the deck is finally hardened, making this fully composite. And once this is done, you can actually apply the second post-tension. And also in stage 6, it's going to get rid of the temporary supports. And after that, all of the superimposed dead load and live load can actually come in after stage 8. So this way, if you need to find out your dead load non-continuous, of course, because the deck isn't poured yet, it's going to be non-continuous. And once the deck is poured, this is the stage that you can run the analysis for live load or the superimposed dead load. And the reviewing result in different stage is quite simple in Midas. And remember, for the precast girder type, remember the spacing portion that I mentioned to you? So when you model your bridge, let me bring back the model that we worked on before. Okay. If you look at my section, right now I display the color to be different per different section properties that I have. So if you look at my this model view right now, the girder is actually all white color except the area that I define the spacing. So I define the spacing to be like 0.5. Let's take a look. When I actually inquire about the notings, it's telling me the distance between the two is about 0.5. So if you look at my section property, this side 1 and precast 1 are applied at between the girders. So if you actually need to consider different section, between the girders, because you're, pouring the concrete without this the cast, you can actually go to the properties and feel free to modify that information. So here, it's already in, so it's already defined with the regular type 5 that I started with, right? But then let's say you kind of have to make this rather a box rectangular shape, then like an I shape, then play around with the BL or H, whatever the dimension that you will need at the point, and just modify the section. So that way you can reflect the different section property at the above the pier. And if you actually need to model raised bend cap, what you can do is right now, if you look at it, by default, the wizard is actually creating the model to be, to place the pier cap underneath the girder, just the regular way. But if you, and then the links are modeled. And also, this is another question that I often get from the engineers, especially from the Texas area. But having the two reactions coming onto the pier cap like this. So what I'm showing right now is the link that are modeled to the pier cap. So remember that we defined the support spacing here before, spacing B for the spacing from the girder end to the support. Using this input, we actually let the program know where the reaction will be coming down onto the pier. So for each girder, you notice the reactions are coming down in one end and from the other span in the other end. And if you need to raise your pier cap, you have two options. You can either simply go to the node and element and simply move up your pier cap section, these elements. So select the elements that are for pier cap, right? And then you can translate, meaning copy or move, and move them by the certain distance. Let's say 5 feet, for example. So this way you can increase the pier cap. And this may be coming down all the way from the deck, just pour them once. You can actually reflect that by increasing the size of it. It's actually exactly the same way how we can actually change the section property right here. And this pier is now hanging in the air, but no worries. We can, of course, change the node coordinate for this pier cap too. So, for example, if you want to properly place your pier cap, simply find out the girder ID for them, right? A41, A39. Go to the node table and change the Z. So that way I changed 2 of them. The column is the pier is now properly placed, attached to the bend cap. Okay. There is a lot more I wanted to cover, but then I think I did explain the fundamental backbone of the wizard and the flexibility of it even after modeling using the wizard. Couple different examples that I wanted to show are such as a curve type like this. So this one, as mentioned before, the girder is straight while the deck is curved. And also I have another model that's used in which I use the box type section. And all these materials will be uploaded on our website.